Hey, hello everyone, welcome back. So in our last tutorial, we created this application where we are having a rating button with the expressions. So whenever we'll preview our camera, at that time it will detect our expression and it will swap like this. And at the bottom, we are having a button on click of which it will click the photo. But for now, we have not performed any action on this. And at the background, as you can see, we are having a black screen, but that is not a black screen, that's a camera which we are going to configure now. So let's minimize this thing and let's head back to our Android Studio. And as you can see, this is our Android Studio and this is our project which we created last video. So here we are having a main activity in which we had not did anything yet, and then we created a camera preview for our camera, and we created a graphics overlay which will detect our face, and it will detect the expression and it will create the square green box onto the screen. So now we need to create the camera source which we did in last tutorial. So I had already created some files here. I'll explain you step by step how it works. So first of all, let's go to our camera source. Now if you remember, in our camera preview we imported here a camera source. As you can see, you are having a camera source, and we imported here this one, com.google.android.gms.vision. So this is the default camera source which Google provides us, but we need to create our own. So I had created here a file with the camera source, and I'll import this. I'll remove this camera source from the imports, and I'll import this new one that I created here. And you also need to create a Kotlin file here with the name as camera source. But I had also created two more files, which is frame metadata and vision image processor. So I'll explain them first. So because it's small and pretty easy to explain. And at the last we'll come to camera source. It's a bit lengthy code we are having here. So let's start with the frame metadata. So this frame metadata will help our camera source to get the width, height, and the facing of our camera. So I had created a class with frame metadata, and it has the constructor which has four parameters. First is width of camera, height of camera, rotation of camera, in which it is horizontal or vertical camera, and then the last one is camera facing, is front or back camera. So and then we have created an internal class in which we had a default value of this all parameters is 0, and then we had created here the four methods which are basically the setters of these values. So first one is set width. It will set the width and it will return that width, same as for height, rotation, and camera facing. Now at the end of this class, we are having the build method which returns the both constructor from here, right? So we had done with our frame metadata, and the another class we are having is vision image processor. So the vision image processor, which it will process our image with the underlying machine model. So as you all know that we are using the Firebase machine learning, that is ML kit, to detect the expression of our face. So this vision image processor which will pass the image to it, and it will process our image which will be in form of byte buffer, and then it will perform the operations on that image depends on our machine learning model. So here we are having the method to process our image. So this is the process method. After that we are having the stop method to stop the process. Now we had done with both the classes, and the final class our class is that is camera source. Now first of all we'll create the class with the name as camera source, and it will have the parameter as first one is the activity and the second one is the graphics overlay. The graphics overlay is the class which we created in our last tutorial. As you can see, this is our graphics overlay. So these two values camera source will take, and inside that we need to create some variables here. So yeah, so the camera source will be responsible to receive the preview frames of the camera uh, whenever we'll open this app, and here will be our camera, and whenever it will detect our faces. So whatever preview of camera will be there, it will this class will receive that camera previews from our main activity frame by frame at the specified rate of frame, and will send those frames to the child classes. We'll create some more child classes here which will use the machine learning model that we are going to design to detect the expressions frame by frame. So this is the operation of this camera source. Now, if you come a little bit down here, we had declared some variables here. If you see here, the first one is the camera variable, that is actually our camera, and then we have a camera facing. So this camera facing will hold the value whether our camera is front camera or back camera. And then if you see here, we are having the one more variable as rotation. So if it is 0, it means it's vertical, and if it is horizontal, it means it is 1. And then we are having the variable as preview size. So what's the size of our camera preview? We are going to assign this while clicking the picture. And then requested FPS and autofocus is true or false. Requested FPS, what is due to some mobiles are having hardware limitations, so we need to request. We had default value is 20.0f, for whom it doesn't support the FPS mobiles, but some of the mobiles has support, so it will be assigned at that time, depends on the mobile. And then we are having the dummy surface texture. So so even though we are outside the method, at that time they still must have some hard reference to our camera. So we'll create here a surface texture which will have an access of our camera, even though if we are on different screen. And then if we are using this structure, this surface texture, at that time it will be true or it will be false. So at the start we had kept either false, and then we are going to create some threads here because we are going to perform multiple operations at the same time, because our camera will be live onto the screen and it will be on main thread, and on the background threads we are going to run our machine learning model. So we are going to create multiple threads here, so that's why I created a variable here. And then we need to process our frame, so I have created a variable for that as well. And the processor log, I'll explain you while running this about this variable. And then this vision image processor is the variable of this class which we created here, interface. And then we are having the one more variable that is of mutable map, hash map variable, which will be used to convert our image to bytes. And then if you see here, we are having now we are having the method as release. So whenever we close our application, it will release our camera. So for that I had created this method release. If you see here, I am synchronizing the processor log and I am stopping the camera, and then I had used this thread to release. The thread should be released, and then I'll clean on the screens, and then frame not equals to null. At that time it will stop my frame processor. After that, if you see here at the below of that, we are having a start method as well. So the start method is responsible to open the camera and sending the frame previews to the detector to detect the face expression. So this start method will be responsible for that. So first of all, it will check whether our camera is null or not. If it is null, it will return here, or else it will comes here and will start creating our camera. We are having here one more method created. If you go to down here, this create camera method will be responsible to create the camera onto our screen. So as you can see, we are having the camera facing. So camera facing is front camera or back camera, and we have created one more method to check which camera facing it is. So it will return, if it returns 0, it means it's front camera, and if it returns 1, it's a back camera. So here we are having front or back camera value. After that, we are having a camera. To create the camera dot open, it will start our camera onto the screen, and then we are going to pay the size of our camera. So we have passed here the width and height of our camera, and if it throws some exception with that size, it will throw this exception could not find the suitable preview size. And we are having the picture size, because the camera has been displayed on the screen, and whatever the size of the camera, at the same size the picture should be. So we had created a variable, so our preview size. And then as I said you before, the FPS speed depends on our hardware of our mobile phone. So yeah, here we have created a range of FPS, and we have created also a method select preview FPS range. So by default we have given is it as 20 double value 20 FPS, but here in this method depends on your mobile hardware, it will get the desired it will get the FPS of your mobile phone, and it will return here into this variable. And if your mobile doesn't allow us to do that, it will throw an exception, could not find a suitable preview frames per second range. Now if you see here, I created a camera parameter variable which will get all the parameters of our camera. Now picture size, if it is null, at that time it will put the width and height of our picture size into the parameters. Now we had set some values to our parameters such as FPS range, the preview size, and we had set the orientation of our camera, it should be horizontal or vertical. And now we are checking that if autofocus is true or false. If it is false, we are making it true, and then we are assigning all those parameters to our camera. Now we are triggering some callbacks of our camera, such as the callback create preview buffer, right? And then once we configure the whole camera, we'll return that camera on camera create method. And in on start method, now the camera has been created and the camera is up and running onto the screen. Now the camera is running onto the screen. Now we need to run it on the different thread, right? So for that I had used here processing threads through which it will run on the camera onto that thread. Now if you come down, we are having the start method that has been done. Now we are having stop method to stop our camera. So first of all, we'll set our process thread as false, because it should be false when we are stopping into detach that thread from our application. And then we'll check if it is null or not. If it is null, then if it is not null, at that time it should detach and make it null. Else yeah. Now we need to check our camera has been detached or not, so it will check it is null or not. If it is null, do nothing, or if it is not null, at that time stop preview and stop all the callbacks of our camera. And also we are having a surface texture of our camera, so make it null. And at the end, release all the bytes of our camera frames. Now we are done with the stop method, and after that we are having the method as set facing. Now the set facing change is responsible to change the facing of the camera. If it is back camera, if it is back camera, and if you call this method, it will change your facing of your camera to front camera, and same vice versa for front camera as well as the back camera. So, and after that we are having the method as create camera that I had explained you some minutes before. And if you come here, we are having one more class whose name is size pair. So this method is used to pair the size of the camera with the preview size, picture size with the preview size. So we have created here two forms. First of all, it will this class has a constructor which takes the two parameters, preview size and the picture size. And after that, we are having the two functions here which will return the specified size there. And we had initialized this class, and inside that we are passing the constructors and returning those values. Now we are having the method as set rotation. So in this, using this method, you can change the rotation or you can call it the orientation of your camera to make it horizontal or vertical. Yeah, so you can change the angle of your camera using this method. So if you see here, we are checking the orientation of our camera when our rotation equals to this, or you pass the rotation to this, and then we are having an angle, and it checks which camera is front or back. And at the last, we set the orientation of parameters. So parameters is the camera parameters, as I said you before. So in using this method, you can set the orientation of your camera. And after that, we are having very important method which is create preview buffer. So this method is responsible to create the buffer for the camera preview callback. Now if you remember, when we created our camera, we set some callbacks to this, right? So this one is the callback that we had created, create preview buffer. So whenever our camera preview is on, is visible to us onto our phone inside our application, at that time it creates a buffer and which records each and every frame which comes in front of our camera. So we need to take those frames and to convert them into byte array, and we need to return this to our callbacks. So that all stuff I am doing here. I am taking the image format and I'm getting the bits from that pixel, and after that I am changing its width and height and size, and I had created a variable with this buffer size which I had converted into byte array. And now if I am checking whether it is valid or not, if it is false, at that time it will return fail to create, else it will return my byte array to my callback. If you see here in this callback, I'm returning that values. Now if you come little bit more down, I had also created here the inner class, yeah, this one. Now this class will be called when the first frame will be available in front of our camera, first preview frame. So it will check that preview frame, and it will this is our thread, and one by one it will pass that frame to our thread. Now we are having the set machine learning frame processors. For now we are not using this method. So but inside this we are not doing nothing. We are just checking whether our frame processor is running or not. If it is not running, which means it is null, at that time stop it or assign it the processor. Now if you see here, we are having the one more inner class here, that is frame processor runnable, and basically it's a runnable, it's a thread runnable class. And inside this, if you see here, this will be responsible while detection is while our frame detection or expression detection is running onto the frame. The new frame may be received from the camera, as this frame come in the most recent frame is held onto the pending. As soon as the detection and its associating processes is done, the previous frame detection most recently received frame will be immediately start some thread. So as I said you that this inner class will be responsible whenever we detect any of the frame, any of the frame, at the same time it will pass that frame into the new runnable thread. Because this inner class is itself a runnable, each frame will get its runnable thread, and it will start processing that frame immediately. So this we have created a lock variable, which as I had shown the command, which locks the guards of the members below, and then if it is active or not, by default it's true. Pending format data byte buffer, which we had created at the top, and we return it. Then we are having a release method to release our thread, then set active to make our frame processes active, and set next frame. Once the process or the detection process on one frame has been completed, this method is responsible to shift to the next frame. One by one it will start taking the one by one frames and will process them all. And it also add the callbacks from here as well, which passes the array of frames to the camera. Now after that we are having the method as run, in which actual process works. Now if you see here, we are having the byte buffer which we have got from camera, and when it is true and it is not locked at that time, and if the process on the frame is still under process, it will wait for some time until it has been done, and once it has been done, it will take the frame metadata and will pass the width, height, rotation and camera facing, and will build that graphics overlay. Now we are having the clean screen to clear the camera screen, and then we are having some companion objects as facing true or false. These are the same variables that we created at the top to assign some values to it. Preview width and height by default is 480 and 460, 360. Aspect ratio is 0.01. Dummy texture name is 100, and these are all this stuff. And we are having one more method here, get ID from request camera. So this method returns us, this method we had called at the top, to get the facing its front camera or back camera, and then select size pair to compare the two sizes, desired width and height, and return the pair of them both, and generate valid preview size. This method is responsible to generate the valid size of the preview of the camera. Depends on the mobile phone, each camera has the different sizes, so the preview of camera should be as per that mobile. So for that, this method is responsible. And then we are having the method as fps range. As I explained before, it detects the mobile fps, and depends on that it assigns the fps speed to a variable. And at the last, at the end of this camera source, we are having the method we are having the initialization method, in which first of all we are clearing our graphics overlay, and then we are running our runnable thread, and inside that we are setting our camera facing, and we are initializing our camera info. So this was all about camera source, and we had already assigned this camera source to our this class. As you can see, the Udemy course, I'll give the link of my camera source here. If I'll click here, it's shifted to my camera source. And now if I run my project onto my mobile phone, I don't think so it will start my camera, because as you can see, we had created a camera preview, we had also created a camera source with all the metadata and all, but it will not work because we had not yet attached the screen. This is our main activity. We need to attach this camera source to our back camera preview, right? So we had not did that, so it will not yet start our camera onto the screen. But yeah, we'll in our next tutorial we are going to attach this camera source to our this camera preview and graphics overlay, and at that time the camera will be visible onto our screen, and it will start detecting our face. So for today's tutorial this is enough, and in our next tutorial we are going to start our camera by attaching it to this camera preview. Hope you like this tutorial, and thanks for watching.